Welcome to Sustainable Packaging with Cory Connors. Today's guest is my friend, Mr. Rob Writz from Robotics. How are you, Rob?
Hi, Cory. How are you? Thanks for having me.
It's an honor, and it was really great to meet you at the Sustainable Packaging Coalition event. And I'm excited about what your company is doing and what you're doing. I think we originally met at Waste Expo a long time ago, and
Right.
where you were showing off this camera system that your company has, and it's an amazing company that you work for. But let's talk about your background a little bit first. What brought you to this world?
Yeah. Well, thank you, Cory. Yeah. So for over 20 years, I've really combined my passion with sustainability and partnerships by working at the intersections of software, so smart cities work, and clean technology. And this has spanned from experience launching the first call routing systems for mobile phones for 911
Oh, wow.
to commercializing energy and advanced material technologies, renewable energy, transportation, and building efficiencies. And I've worked with Robotics now for 7 years. And my focus at really is collaboration across resource recovery industries to increase material supply and grow access to recycling and modernize recycling infrastructure. And finally, really to develop market demand for secondary materials. So I've had a lot of different roles at I joined when we were an R&D company. Without a product, we were really in depth of technology risk and attempting to de-risk what we were doing. And I've really had a great experience being with the company and growing from a handful of employees to nearly 300 now, and employees in Europe and the United States, robots deployed in many material recovery facilities, and all kinds of really interesting new things that are emerging. So you can see my intersection with the role of kind of helping the industry grow and how it relates to robotics wanting to deploy more technology into recycling.
It's an amazing system that your company has developed. I was honored and privileged to get to see it work, and very impressive. I can't wait to share the story about it. So can you tell us what your robots do and what your company does?
Yeah, certainly. So Robotics is both a developer of software as well as a developer of hardware. So our goal here really is to develop and enhance this technology and ultimately infrastructure for the recovery of renewable materials with a focus on post-consumer recycling. So really what's commonly in your recycling bin. And we have developed this software that uses computer vision to recognize patterns of specific renewable materials in complex waste streams. So streams being the flow of material in material recovery facilities where your commingled recycle is taken to split apart into paper, different grades of paper, plastics, and metals. But we've also deployed this in plastic recycling or reclaiming facilities.
Oh,
and
really?
as we'll probably talk about a bit more, kind of going after material that comes out of material recovery facilities that may have gone to landfill and trying to extract more value from that. So those are these complex waste streams because that material is really mixed and can be often smashed and dirtied. It's commingled. It's not how it looked when you put it in the recycling. And
Right.
the software itself that we've developed, it's really the primary competency is in this software, and it acts as a brain, and it's been trained by exposure to thousands of these images of crushed and distressed packaging in these environments. And what it does is predicts in real time what this kind of post-consumer packaging is. So
Wow.
it doesn't go to a database or look it up. It acts actually just like our brains. They're referred to as artificial neural networks, where it's been exposed over and over to these images to be able to predict in that moment what the object is. And not only can it predict what it is, like what type of paper is this, or what type of plastic this packaging material may be, but it can actually go into deeper classifications based on this interpretation of the patterns in the imagery that it's exposed to. So it can further define or classify these objects, such as, is this a food grade object? Was this designed to contain food and beverage or not contain food and beverage? which is
Wow.
something that's very useful for plastic recycling, particularly mechanical recycling of plastics. Is the object clear? Is it opaque? Forms and shapes can tell you it's a tub or a lid. It could tell you it's a Tupperware, for example, versus another type of polypropylene packaging. And then it actually is quite helpful for describing contamination or hazards, what should not be there as well. So, for example, is this a battery? Is this something that could represent a hazard in these recycling processing environments? Or is it simply just a contamination that shouldn't be there? Because contamination and understanding the amounts of contamination and material recovery is actually quite important to the efficiency of operations. So we take that software and we integrate it with robotic sorting to intelligently really perform the physical task of sorting these items in these recovery facilities where the material is really consolidated for markets. So in summary, we're both a hardware and a software developer working on the artificial intelligence as well as the integration of off-the-shelf robotics into the designs we want to accomplish these recycling sorting tasks.
That's incredible to hear. I didn't realize it had a brain like you're talking about. AI, artificial intelligence, is the talk of the town right now in the world of packaging, because there's some new developments where you can actually design packaging using artificial intelligence just by inputting a few keywords. Say, make me a wine bottle for Robotics and Robotics, and then it will come up with something. And what they're putting out is 100,000 times better than what it did 6 months ago. So to think about what it's going to do 6 months from now is incredible. Are you finding that same progression with your technology?
Yeah, certainly. The advantage of using this type of technology is that it's being applied across a lot of different industries and applications. So you have a huge community that's advancing this. But per your note, hopefully with that example, you could also say recyclable, and then the bottle comes out, part of its design is designed
definitely
for recyclability. Right? But this technology is not dissimilar from what Tesla and others do with autonomous vehicles, where they're taking an imagery and interpreting that imagery of street signs and crossings, cars, traffic, and others into like a decision for the car to make an action by. We also see it in agriculture with interpretation of imagery for crop health. So there is actually a huge infrastructure around it. So it is rapidly accelerating. And what we do is specifically take that and apply it to sorting recycling material to prepare that for markets, for recovery into new packaging itself and other pathways. But that is specific to us. So could you take like Tesla's model and apply it into our model? There's probably similarities in the software architecture, but it's a different environment, right? So if you asked a person who also has a brain to port from one task to another, they need to learn, right? So similarities in their base architectures, but the data and information that these systems absorb are hyper-specific to their tasks.
That's incredible. Again, fascinating. Do you have any data as far as the improvement percentage or the amount of material that your systems are recovering over old generations?
Yeah, we can certainly look at our own system, right? And it's hard to compare it to historic systems, because historic systems are an optical sorter that performs well, very high volume sorting based on interpretation of infrared signals. And the other technology in this industry are human beings.
Yeah.
So people out there looking and sorting.
Working really hard. Yeah.
Working really hard, which technically could be a vision system as well, just like ours. It's a person with eyes and a brain. But for us, we have about 300 of these robots and sensors deployed. They're recognizing around 50 billion objects a year. So it gives you the scale and sense of how much volume and material runs through these recycling facilities, let alone past one of these robots.
I toured a MRF in Atlanta at the last SPC event, and what was fascinating to me was the operations manager basically said the employees get really tired. It's a really difficult job. You can't do it for that long at a time. You have to take breaks because it is so intense on your mind. So it sounds like what you're providing will be a big relief to these MRFs. What should the MRFs know about your product when they're considering a purchase?
Yeah, actually, I do want to address kind of value proposition real quick about the labor complement of the robot. What we see with MRFs is that they're really actually quite challenged to overcome costs, for the benefit of having sorted out all this material, and historically to keep driving those costs down, because labor has actually been a big part of recycling. You do have very high volume, consistent material like UBCs, universal beverage cans, aluminum cans, but packaging is complicated, as you pointed out, right? People have to really think about it, particularly when you go into plastic packaging and other type of hybrid packaging. And these MRFs are often high turnover environments. These positions where they're sorting are high turnover. Not only do they have to think really hard about this complicated material, but they have to do it as it's passing by a person at 150 feet to 300 feet per minute.
Right.
And it's cold and it's hot, and it is on the spectrum of solid waste. It's not a pleasant
Smells bad,
activity.
right? Yeah.
So it's a high turnover position, and these robots and the accompanying vision system are really offering, in its core, when we launched the company, this labor complement to help with those turnovers. But one interesting thing about the software is that it takes a lot to train a person on the complexities of the packaging. Once you have the robot in place, it's not, that knowledge isn't leaving, and it's actually building based on the deployment of our fleet. So it's a network effect.
Wow.
The more we deploy, the more data we have to consume and train these neural networks. So as new packaging comes out and we isolate that as a challenging material, maybe we're not as confident in that. We're able to then go find examples through our system, train the neural network, and deploy that out to the fleet of robots. So it's actually these behind the scenes, albeit independent MRFs, they're actually kind of connected through these robots with a shared intelligence as packaging's released. And so, it certainly also helps with safety in the facilities, getting more high value material out at a higher quality as well. So it really affects the recovery rate of the MRF, that they can get more material at that higher quality, and that inherently helps improve recycling rates over time. So the MRFs are fairly aware of this now. I think at this stage in the classic kind of technology adoption curve, we're not in the early adopters now. We're in what's probably the early majority, moving more towards the majority. So most MRFs have either adopted or strongly considered robots and robotic sorting based on those value propositions we were talking about. But what I think they're learning about now, what we are talking to them now more and more about, is the value of the data that accompanies these robots. So each robot has that vision system and computer processing. It's digitizing these objects that travel past it on the conveyor belt. We're also able to decouple that camera and computer system and deploy them into different points of the MRF as well. So it's really this kind of the start of the digitization of this industry, and the industry 4.0 concepts starting to transform these traditionally material-driven facilities into more data-driven smart factories. And we're able to do it by deploying these systems in a legacy infrastructure so we can help those existing MRFs and kind of get up to speed on analyzing their material flow. So as we drop those into different points, it can help them with understanding their inbound composition and their inbound flow, the outbound material, the quality that's going into the scrap bales, and even at points understanding what's being lost to landfill. Like where can they improve further upstream back in their process if they're losing a certain amount of material. And that happens in near real time. They can analyze it right then, as well as historically as well. So this monitoring and auditing capability is a bit of a new concept for MRF. Historically, focused on high throughput, get the material in, get it out. But this is really the start of this interesting data-driven decision making. And that's where a lot of discussion is going now, because they have been adopting the robots. Now it's leading to, wow, okay, we've gone through the value proposition of the labor substitute. What else can we do with this? And
Yeah.
it starts enhancing their infrastructure at lower costs by being able to put these deployable sensors throughout the facility.
Do you know how many MRFs there are in the US?
Yeah, I think there's about 400 or so. There's always depending who you ask and what type of MRF we're talking about. But I think the recycling partnership that we'd probably look to is the authority on that number would say 375 to 400 or so.
It sounds like there's more being built. Is that accurate?
Yeah, I think we're seeing a lot more activity in that now. I think historically there were not, but we're seeing increasing demands for post-consumer content that's driving a lot of this. There are new MRFs being deployed. So what I described earlier was going after how to retrofit an older MRF. The new MRFs that are being deployed now are putting this data-driven decision-making right on their list of design features. How do we not only understand that material flow, but get other advantages of connecting equipment, building more of the smart factory approach to recycling, because to material recovery, because it really is a factory, right?
Yeah.
Things are coming in, they're moving on conveyor belts and they're going out into these compressed bales. So it's really a factory approach inside the building.
Right. And the end result or end product is a sorted waste stream, which depending on what they are, have different value propositions. And like you said, the aluminum cans are incredibly recyclable, whereas some other materials, not so much yet. I got to be at the Association for Oregon Recycling event I think that was in November. And they're talking about adding not only more MRFs, but more specific sorting facilities just for plastics.
Mm-hmm.
So once it comes out of a MRF and it comes into a mixed bale, they're going to take those bales and further reduce them down into exact polymer so they can be recycled or reused somehow.
Yeah.
Does your technology work with that?
Yeah, I think this type of technology, as well as others that have been innovating alongside us, really start to enable that. One example in there, using our technology and this interpretation of the patterns and shapes, is you could take PET and then divide that into what are PET bottles for the kind of L&O, letter of no objection pathway, or bottle recycling.
Yep.
And based on these forms and shapes, you could pull out the PET thermoform for recycled content in the thermoform sheeting. And you'd say, well, Rob, those are both PET, but they actually, in a mechanical recycling pathway, have different intrinsic viscosity, so they don't mix. And an infrared sensor will tell you they are both PET, but by adding this new technology, you can differentiate that form factor or purpose, which can often be indicative of the more detailed granularity in the plastics itself.
Incredible. It's fascinating to hear that. And yes, PET has been a big conversation on this podcast because it is so recyclable, and in history has been very recycled for water bottles and things like that. But now more and more we're trying to recycle thermoform trays, like you said. And that success is happening faster and faster. So it's really cool to see that process and how it's actually working. And they're actually able to sort and recycle directly back into thermoform trays from old thermoform trays, which is awesome.
Yeah, that's right. There's enough of that material out there. As this technology develops, we can create these more specific recipes, really, to help accomplish that circular journey. What we're starting to encounter is that there are great innovations in the downstream recycling, a more advanced recycling, molecular recycling, as well as within mechanical recyclers. Mm-hmm. There's these really interesting innovations like ours in the sorting. The challenges that are starting to emerge is, how are you going to get that stuff in the first place? How do we convince people to put it in the bin? So what's great is that the technology innovation's happening.
Yes.
It's really moving forward. Now the light's starting to move towards what are the innovations, whether technological business model, social or otherwise, to get, participation, get curbside access, and get more of that PET in there so we can get more recovery. So I do think it's actually a really exciting time in recycling. There's a lot of innovation going on across the spectrum, and we're one part of that, focused on the sorting. But it certainly does take mobilization across the whole value chain to really reduce the costs of recycling.
And like you said, and encourage consumers to recycle. If it's not curbside and it becomes an additional step, are they going to actually do it? And it's neat to see companies like D6 they're actually paying people to bring in their thermoform trays in Texas. That's just starting this brand new program, but you're going to see a lot more PET thermoform trays available in the recycling network if this all goes as planned, which I think it will. I know Ed Minion over there, and he's a brilliant person, just so smart and tenacious. He won't stop until he succeeds. So I'm excited to see him in charge of this process. But let's talk about the future of AMP Robotics. What's next for you and your company?
Yeah, that's a good question. It's a bit twofold answer. We've done a lot of work. Certainly, I mentioned the robots that we've deployed out into MRFs. There are certainly more locations in existing MRFs and customers for us to deploy robots, and more robots to deploy. We are actively expanding into Europe, where we have staff there. Certainly, that's a different policy and market than the United States, but they recover and recycle a lot more material there. So that's really exciting for us, is to take our current offerings into that market. But we have actually matured the technology really to a point where it's now feasible to develop entire material recovery facilities based on it. And this is a big step from the technology point solutions we've been talking about so far, really into the development of new infrastructure. And we've taken this step forward, and we have designed and deployed these next generation material recovery facilities, where we, again, are digitizing every single object that enters through those conveyor belts. And because we've done that, we're then able to control every object in there. We can decide if it's something we want to sort, when should we sort it, is it too close to another object? Maybe we don't want to sort it at this moment. We'll let it pass back through and get it again. There's a lot of intelligent decision making happening in these facilities based on that digitization. And what it really leads to is higher recovery rates and lower processing costs, and new approaches to the materials we can produce, like these recipes we've been talking about. Can we help serve in the emerging like pyrolysis and methanolysis markets? And one example of that is our facilities. These MRFs that we have deployed and operate now are collaborating with primary MRFs in their region, and they're accepting residual material, or material that would have been going to the landfill. It wasn't able to be sorted by those MRFs. So we're taking that traditionally landfill bound material into our facility, and we're sorting it out and extracting the value out of that. And it increases the amount of materials available for the market. It reduces the landfilling broadly, but in particular for those MRFs that we collaborate with, it's reducing their landfilling costs, so they don't have to pay for that landfilling. So that's a big step we've taken recently, is to really move this technology from the point solutions out to the infrastructure design. And we have certainly proven that it works, not only at MRFs, at plastic reclaimers, as we talked about, in this residue recovery, but really our big next steps, I think, are how we scale our impact. So moving from this kind of technology de-risking, early adoption stages to now, more market adoption. To really scale, it means exploring new business models and partnerships with the industry, with waste haulers, with MRFs, with NGOs, CPGs, brands, and others, on how to recover more of this material. And so our long-term goal is to make recycling competitive with landfilling on a per ton basis. And that that takes scale, and that really takes, to get that scale, it takes partnerships. So those are some of our big next steps here, are really expanding on this infrastructure model and partnering in the industry to really position sorting as competitive choice with landfill.
Oh, cool. That's great to see. Can companies reach out to AMP Robotics to see if their packaging will work with your system?
Oh yeah, certainly. We engage with CPGs and brands and others and look at the recovery of that material. I think the best way is we have a contact page on our website, amprobotics.com, but you could hit me up on LinkedIn. I don't think there's another Rob Writz on there that I'm aware of. So that's me.
Yeah.
Albeit with an older picture, but that's probably me. And I can connect with people there as well.
I'll put a link at the bottom of the show notes so everybody can reach out to you, sir. And really appreciate your time today. This has been excellent.
Great.
Thank you.
Thank you, Cory. Thanks for having me.
Thank you, Landsberg Aurora, for sponsoring the podcast. If you're listening, make sure you subscribe so you don't miss the next episode. Thank you all.